Hello everybody, this is Karen O'Brien, and today we're going to be talking about how do you manipulate elevation data using QGIS. I hope that some of these tools will be used specifically for Flow2D because they come from the Flow2D correction tool, and some of these tools can be applied to any kind of elevation data or any raster. So they should help you in all of any kind of engineering I guess, endeavor that you have that might require an elevation modification. So this is not how to get elevation data. That is already done in a video on elevation data prep for, so you can look at that video from my website and my training packages. Let's go ahead and start with something simple. We have in Flow2D plugin, we have two tools. One, a raster warp, and the second tool is a point statistical analysis. I just want to tell you what these two tools do, and then we'll talk about how to apply corrections to grid elevation after you have these tools in place. So typically, I just want to identify the, excuse me, I want to identify the audience for this, the kind of the goal. So we typically have, three kinds of people that are building data for these projects or for any kind of elevation data. And that is the design team that is predominantly using Civil 3D. And then there is the water resources or water management team, and that's us. And we, for the most part, use GIS. And then there is like the reviewing team that might not really use either of these programs like all the time, but they need them when they need to perform something. So we're going to try to meld and blend these three teams together to identify, what data we're getting from our design team, how to apply that data, and then just an overall, I guess, expose of the tools so that you kind of understand what they're doing and how to use them. So let's start with this grid, this sampling elevation from a raster layer tool here. So obviously you have to have a grid set up to use this tool. This is specific for Flow2D. So you have a computational domain and you've already calculated your grid and you have a grid elevation. Then you have a raster that will likely come from either you got this from an online source or your client provided it to you or your design team provided it to you. If you click this button, what this does is it's a raster warp. And so if you take this elevation file right here and you apply it to your grid, what it's going to do is it's going to warp the original elevation file to your grid, set the grid cell size as the pixel value for the warped raster, and calculate an average from all those pixels that intersect your cell. So there's two important things about this that you probably need to know if you are concerned about your elevation mapping. First of all, the way that this works is it will use the raw input only. So this is important because a standard gdal warp is going to, the default of a standard gdal warp is going to apply the warp to the overview layer that is closest to the result layer. So the overview layer of a raster is the indexed data that shows up as you zoom in and out on your map. So you have your raw data of your raster, and then you might have overview layers of your raster that will show you a different picture at different zoom views. So if you're going to use the gdal tool and you're going to do any kind of warp, you need to make sure that you're applying the warp to the raw input resolution. And that's what this tool does. So if you don't see this use raw input only, you need to update. This no data value is applied to the raster that we will be warping into. So for example, if I warp this raster here, which is a 2x2 that is clipped right to this grid. You might be able to see that if I take off this one. Let me take something off here. This is the full raster, and this is the interpolated raster. Let me remove this one. This is the so what I did was I warped this one right here from this one because I wanted it to align exactly to my grid. So you can see and then this is a 2x2 raster. That's its resolution. And if you want to know the resolution of your raster, you simply double click the layer and you go to information, and it will give you the pixel size. The pixel size is the resolution of your raster. And this raster is in feet. And also the raster data does need to be in the correct coordinate system. It does need to be on the computer with the data that you're using. If it doesn't seem to work if it's on a server. So this was something that I warped from this layer. I warped into a grid that was 2 feet by 2 feet. And then I used that to do some statistical analyses. Okay, so if we hit this button and we select this raster right here, what we're going to do is warp it into a 10-foot grid or a 10-foot raster, because my cell size now switched from 2 feet to 10 feet. So my no data value being -999, the only thing that's going to do is apply that no data variable to the new raster that we'll create. You click multi-thread because the gdal has a built-in multi-thread tool, and you have different options for your resampling algorithm. I typically stick with average, and I think if you're using the current plugin, you'll get the raw input only. The older plugin would allow you to choose between the two, but the current plugin will only allow you to choose the raw input only. And then you click OK, and that will sample your data. So when that samples the data, what it does is it warps the data, and it creates a file called, let me grab it. I got to make sure I'm in the right folder here. DEM, the same name as your file that you warped, with the underscore interp as the final name. So this would be the 10 by 10. This one right here would be the 10 by 10. And this one here is the 2 by 2. So that's how this tool works. Now, a warp is a weighted average. So that means that any cell or any pixel that touches your grid pixel, even if it's just a thin slice, will calculate a weighted average to apply the elevation to the cell. So that's important because later on we're going to look at another tool that applies a non-weighted average. Okay, so that's tool number 1. Let's move on to tool number 2, which is to assign elevation to the grid from a point layer. Now this one will now what I did to set this data up was I created a point sample of this 2-foot raster. Let me show you what I mean. So there are the Flow2D tools, and then there are the processing tools. And so if you put into your processing toolbox something like point sample or point raster to point or something like that, you have many tools by which you can sample the centroid of a raster, and it will just convert your raster data into a vector layer with elevation points, and that's this guy right here. And that's how I built this data. And I built it because I wanted to compare this 2 by 2 to this 2 by 2 point sample to this 2 by 2 warp. And then what we have here is the point sample. Now this is simply zonal statistics. So what it's giving you is let me grab that, points. You can set up the vector layer or the point layer, and you can set up the elevation. And this one I set this was an elevation that was sampled from the raster. And this was an elevation that I converted to 4 decimal places. And then you can set the calculation type. And this is a standard average. It doesn't do anything weighted. And the maximum, you just leave this as 0, and it will just take all of the cells or all of the points within a cell. And if you click OK, it will do a statistical analysis on these points and then assign that mean from that statistical or from that zonal statistics to the grid. And then if you want to like check any of these, there's some excellent little tools in here to perform statistical summaries and statistical analyses on all kinds of vector layers. So for example, if I had a, let's say I had a depth map applied to my grid somewhere, and I wanted to, let's get rid of this for just a minute. Let me find something that would kind of make sense to analyze a depth on. I don't think I have a basin in here, but if I wanted to analyze the volume of an area, let me get to another map. I have a better map over here. If I wanted to analyze the volume of an area, I could import my depth map onto the grid, and I could select the cells that were, like, say, within this basin, and I could use the sum on that polygon layer, and it would sum all the depths within that polygon layer and give me a total volume in cubic feet of the depth in that layer. So that's just something of interest. Well, you would maybe convert it to, you would probably convert it to cubic feet by summing it up and then applying it to the grid, the pixel size of your grid. So it's a very handy tool. These statistics are super handy. But what I used them for was to compare the warp value to the point value from these 2 sampling methods. So I just did a comparison to see, exactly what is the data, when is it different, why is it different, and does it work properly? And in my statistics, so I set up this project to be perfectly aligned to the grid so that I was basically sampling exactly the same data from the raster and exactly the same data from the point layer. So I should get a comparable number result that would be similar. And my findings was that both the tools are working correctly, and when I sample them, I can see that my decimal value is off by like 0.00005. So the sampling methods seem to be working good. But these two tools, when you're applying them to a regular project where your data is not perfectly aligned to your grid and you're not sampling exactly the same data, they're not going to result in the same results for a grid based off of 2 different data sets because of the weighted average. So the raster is a weighted average and the points is not. So that's why they have different results. Now, so I just wanted you to understand how these tools work and what they do. I also wanted you to see that there are many amazing tools in the toolbox that can sample rasters, calculate volumes out of rasters, fill rasters. There's all kinds of fun tools in here. I don't have time to show them to you today, but we're going to see some of them. So let's change projects to the elevation correction tools. And so what I have is a couple of projects and some different data sets to try to apply these tools to multiple different scenarios based on my experience of what I've received from clients or what I've done during tech support to try to help you, correct your grid. So let me get back to my notes here for a second. So we're going to start with correcting the grid from a 10 based on elevation and points. So why would you have to do this? Let's just conjure up a scenario here where we might use this method. And what I have done is I have a set of points to represent the elevation of this basin. Now I'm going to open the attribute table on this. And what I want you to note is that I have named these points design alternative 1. So I could have design alternative 1, or I could have design alternative 2. We're going to, now they also have an elevation field and a correction field, which I don't think will be applied. So we have the important thing about this is that the membership must be set to grid. The name is not important. It just helps you to define what you want to calculate from. And the elevation field must be filled. So I'm going to, this is sorted by name. That's how if you see here, that little arrow means that's what you've sorted by. So I'm going to select all of these that have the name design alternative 1. Now you can do that by just selecting and then going down to the bottom. Wait a second, they shouldn't all be design alternative 1. Let me, hang on, I might have messed something up. Let me see. Oh no, these are points. Yeah, that's fine. Sorry. Yeah, these are points. There's only design alternative 1. So if you had design alternative 2 in here, you could also apply that. You could apply that, and then I will only select the ones named design alternative 1. And as you can see, they've all been selected, and I will minimize this, or actually I'm done with this. And then elevation polygons, it's important that I select the polygon that is associated with this correction. So that's very easy. You just click the selector tool and click the polygon. You saw that it turned yellow, and then come to the elevation corrector. And the first option under the user layers mode is tin based on the elevation points and polygons. So if I click that and click only selected polygons and click OK, it will calculate the new design elevation. So if you got your elevation data from your design team as points, that will sample the elevation from a tin that was created by intersecting the points to the polygon, calculating a tin, and then sampling that tin from the grid. The next method, let's see, that's tin based on elevation and point. Okay, that one is finished. The next one is a tin based on elevation polygon boundaries. So I have another project because this is something that I believe dam or levee or tailings dam people might be interested in. So this is, so if you're going to fail a dam or fail a levee, you can't fail that dam or levee if the elevation that of the dam or levee is burned into your grid. So we need to kind of subtract that out of our grid. There's a lot of ways to do that. You can cut that elevation out of a raster using any kind of raster tools that would be available in QGIS, ArcGIS, Global Mapper, Civil 3D. You can cut these contours or these pixels out of the map. But again, we are kind of dealing with people who may not have those options. They may not have those softwares. They may not know how to use those softwares. So we have a tool that can do this for you. So what I have is an elevation polygon that is simply covering all of the elevation data that is kind of just outside of the places where the dam starts. And it's not very, as you can see, it's not very perfect. And this is kind of a strange case because my elevation data for this particular case, this is a dry dam. It's probably as much a sedimentation basin as it is a flood control feature. So it's probably trying to keep the sediment from running down here. So it has elevation on both sides that represent bare ground. So if you had a tailings dam and you wanted to fail it all the way down, you might need to have some contours that represent the tailings dam before it was constructed, or the ground level that you want to fail it to. So this one's easy. You set up your polygon, and again, I think I'll select it. I'm going to select that polygon, and I'm going to apply this correction. From the user, the 10 based on the polygon boundaries, I'm going to apply it only to selected. But first I wanted to show you the elevations and how they change. So you can see here, I applied the tool before I corrected it. Let me reset the elevation really quickly so that we can see the original elevation that includes the dam. Okay, so if I refresh the screen, you can see here that we have 1400, 1399, 1397, 1394. And then our edges are 1377 down to, let's get off the dam, sorry about that, 1376. Okay, so we apply the tool, 1377, 1377 on both sides. So we apply the tool, the correction tool, to the selected polygon. And once it's complete, I'll refresh the labels again. And you can see that what it's done is it's taken the dam out. So now if you set up your dam or your levee from the levee user line right here, what it will do is this will become the elevation. And when you set your failure point, which I set my failure point right here, so you can see your levees and you can see your failure point. And don't ignore this. This is a mistake that I messed that up. But you can see your failure point right here, and it will fail the levee, and the levee failure will spread in both directions. And the elevation of the dam is extracted from the grid using the boundary of the polygon to reset the elevation to take the dam out. So that's an important, and I'm sorry I spent so much time on that, but that's kind of an important method for people who are running dam breach and levee breach. Now, if you don't have a good, so let's just say you don't have a good way to do this, like it's not perfect like this, your tailings are on this side, or there's water on this side, so you don't know what the elevation is upstream, you can do something a little bit different. I will now select another polygon that is slightly different. I think I'm gonna have to select it from the attribute table because I believe it's covered by my dam cut polygon. It's this one right here. So we did the remove dam with 10 polygon, and then this one is the detention dam cut polygon. So in this case, if I just want to fail the dam using a simplistic method, you see here that I have an elevation assigned to the polygon, and that brings us up to the next tool. If I apply this one, so first of all, let me resample the elevation just so that we can reset it. And that'll get our dam back in our elevation data. And then this one will apply an elevation from that polygon, use only the selected, and hold on, let me cancel this. I know it's selected because I selected it from the attribute table. So elevation polygon attributes, use only selected, and click OK. And what that will do is it will take the dam out of the elevation using a method where it just resets the elevation to that. So now in this case, my elevation reset was only a small portion of the dam, because the whole dam's not going to fail unless it's a massive failure. So just estimate what you think the dam will fail and reset that to kind of the bottom elevation, and then the water will fail, or the dam will fail all the way to the bottom or to a base elevation that you set in the failure. And again, that's all different webinar, levee failure, dam failure criteria. So that takes care of the 10 elevation boundary, the elevation polygon attribute, which I can show you one other method on how to use the elevation polygon attribute to fill. We did it to extract data. You can also use it to fill data. And now we have one final method, the grid statistics within the blocked area. So blocked areas are here. They typically represent buildings. The reason we developed this tool was to, let's turn our blocked areas on real quick. The reason we developed this tool was to set the first floor foundation elevation of a polygon that represented a building. So in this case, and there's two ways to use it. You can either apply the elevation from a, you can either apply that first floor elevation from an attribute that is this polygon, or you can calculate statistics within this area of selected cells, and it will apply the statistical calculation to it. So first, let's select a few buildings just because I don't want to apply it to all of them because I don't want to wait for it. So I'm going to select some of these larger buildings, and then I'm going to zoom in so that we can see the grid labels. I might have to turn them on. Actually, let's see. I thought I had them already turned on, but let me do that real quick. So to turn on the labels for the grid, I'll just set that to single labels using the elevation field, and then I want to use scale dependency. So if I zoom out to like, let's say 500 and zoom in to say 50, that will, those labels will turn off at these two scales. Now let's go ahead and apply the correction to these buildings so that you can see how this tool works. Again, we will do only the selected polygons, grid statistics within blocked areas. We can choose a mean, max, or min. Let's choose a max just to so we can see some changes. Once that is finished, we should be able to refresh the screen by just simply zooming in and out a little bit. And you can see that they now have all the exact same elevation, which would be the the maximum value of any cell that intersected that blocked layer. So now we have that first floor elevation of that building is applied, or you can, or again, you can apply it from an attribute. So if you wanted to apply that from an attribute, you would probably do the elevation polygon with attributes. This one is just the statistics within that polygon. Okay, that takes care of the first tab. Moving on to the next tab, I have to set up the data. So first of all, let's zoom out and unselect all. This is the unselect from all layers button. And we don't need the buildings anymore. So just to kind of keep things simple, I will uncheck blocked areas. Now, this is one of the ways that I get data from the design team. The design team might give me data that is just clipped to the new project area. So the way that you analyze this data is a little different from, so first of all, if you had a design and the design team just gave you the full raster that had the updated design data, you would apply this method. If they gave you the design data in points, you would apply this method. And if they gave you the design data as a clipped raster, you can apply the method we're about to go over. And this, I actually get this question from a lot of people, so it's a good thing to try. So look, we're going to say that this this neighborhood, let me show it to you just so you get an idea of what it looks like. we're going to say that this neighborhood is being redeveloped, or it's a new development applied to like maybe part of an open field or something like that. An ag field is being developed for buildings or whatever. How do you apply that to your grid? And the design team gave you just the new elevation of the area that was modified. So first of all, I'm going to show you the clipped raster, and I will turn off the image. Actually, I can move this image to the bottom because that's probably where it belongs. I'll just move that to the bottom. I don't know if you noticed how I did that, but I just grabbed it and I dragged it until the little arrow appeared. And then here's our clipped raster. And this is, so unfortunately, this is not the most efficient way to do this, but it works fine. And I'm going to tell you, one, about how to do this, and then two, about what we're going to do to make it easier in the future. So first thing I did was I got an elevation polygon of the whole area. I'm going to grab this, and I want regrade neighborhood. I want to select, oops, I didn't mean to do that. Regrade neighborhood, I want to select that polygon. Oops, dang it. I just wanted to get that out of the way. And then I wanted to show you what we have. So if I uncheck all, you will see that we have one single polygon selected. I'm going to check off of it. So this is the area of the polygon. So if I applied any of the correction tools to that single polygon from either elevation, either these two or this external method, it's not the right way to do it, because the statistics that will give you is just a max, min, or mean for the whole polygon. So it doesn't quite work the way you want it to. So what we do instead is we use that polygon to select the cells that we want. So I'm going to highlight the grid layer, and I'm going to use the selection tool, but I'm going to use the selection tool based on a polygon, and I will select these cells, and it kind of snaps you to the corner, so that's good. Oh boy, I zoomed in and out too much. Based on the corner of these cells. And I kind of want to mess up a little, so I'm gonna just try to mess up a little bit. Like, I'm sure it'll mess up a little bit, like right here, just so you can see how to fix it if you mess up a little bit. Then right click will select all those cells from the grid layer. And as you can see here, I've selected almost too many. Then I need to copy those cells, so I'm going to click the map and hit Control-C on my keyboard. That is the way that you copy cells in QGIS 3 and later, QGIS 3.10 and later. And then I will go to the layer that I want to put them in, elevation points, and I will, no, I'm sorry, elevation polygons. These are grids are polygons, not points. I will come to the editor and click, and Control-V will paste them. And we should get a message there that it pasted them. Let me see. Nope, it's still doing something, so we'll just wait for it. Yeah, not responding. We're good. Okay, that's what I was looking for. That wheel will tell us when it's done. So it's pasting the polygons into that layer, and then we can clean up those polygons. And I've already got them in there, so because I did this once before, but I'll show you how this works and how to clean them up and how to sort them and review them. Okay, that's it. The features were pasted, and now I can go into the polygon layer and open the attribute table. And I don't know if they're still selected in the new layer. They are. Excellent. So in the new layer, I'm going to move that selection to the top. And I already have all those in there. So I'm going to invert my selection because I want to get rid of those old ones. I probably should have deleted those old ones before I did this, but I didn't. So I'm going to invert my selection using this tool. And then I will use the control click to unselect the ones that I don't want to get rid of. And I'm going to delete the old ones. Okay, so now I have my polygons that I want, and I don't need to worry about the membership because I'm going to use a different calculator. So the membership right now of those polygons I just pasted in is all, not grid or levy. And also those polygons I pasted in do not need an elevation. But if I do sample those, if I do select, and I will turn this move to top off now because I don't want to mess anything up. And if I pick these up, and this time we should be sorted by name. There we go. If I pick all of these up and I want to give them a name, only because so that I know what I've used them for. And this will be let's see, what is this? This is the resurface new development. So this, and then that is a string, so I have to use quotation marks in the name. Single quotation marks represent a name or a string. Double quotation marks represent a field. And then I click Update Selected. And you can see that that name is Resurface New Development. And then I can just unselect all and save it. And you can see this thing right here is kind of jiggling around, so it's saving the data. And then once that's finished, I will undo the editor button. And sometimes with QGIS, it starts to take a long time to do simple things like this. If that's the case, you might need to restart QGIS. I've been doing this all morning, just playing with it. So it shouldn't take that long to rename these. So if it starts doing something like that, just restart it. We'll wait for it in the meantime. Also, keep in mind that if you start seeing, you're not going to ever see red things like this because I'm running in the developer mode. I'm running the nightly build in the developer mode, so I'm getting every single error that is coming up. Most of these errors don't really mean anything, and so I can just ignore them, and you won't even see them in your regular mode. What you'll see is occasionally you'll see a yellow error up here, and then you'll see blue messages that tell you something was done correctly, or a yellow message that something wasn't done. Sometimes you can ignore them, and sometimes you can't. You have to pay attention to them. And as you use QGIS, you'll start to understand which ones you can ignore. Yeah, I definitely needed a restart before the class started, but that's okay. It will be done. Let's see. Is there anything we can do in the meantime while that's processing? Let me go back to our other map. Oh, there we go. I think it's done. Never mind. Okay, it's finished. That didn't take too long. I'm in select for some reason. Let me unselect all. I'm going to change this back to select features because every time I click the map, it'll try to draw a polygon. And now what we have, in addition to the big polygon that selects the whole area, and that one is applied to the grid, we now have the little polygons. But as you can see, they're kind of messed up. We have a few too many. So I will select only these options with this tool, and I'll delete those out of that area because I don't want to apply my correction to anything other than the polygons within my new clipped area. All right, and one more. Looks like I had some overlap in a few other areas. And then save that. And at this point, we're ready to apply the correction. Oh, I think we need to turn off the editor, go to the correction tool, select polygon, elevation polygons, and this can be any shape file. That's why we're in the external layers mode. If you choose the grids within the polygon, it will only sample, if you use the grids within the polygon, it will sample anything touching the grid. If you use the centroids within the polygon, it will only apply the update to a cell that is to the centroid that's within the grid. I hope that makes sense. And sometimes that's important because you don't want overlap. So in my case, I can do either or because I've kind of my polygons represent the whole grid element. But I'm going to choose centroids because it's usually the most accurate. And what I want is the statistics within the polygon. I want to sample my clipped raster, and I want the mean. So now this is not a warp. This is a zonal statistic of this raster. And so it's very accurate. And then again, I will use only selected features. So I made a mistake. I actually need to go in and select my green features. Let's turn off these, and we will select only the green features. And just to be on the safe side, oh shoot, I didn't know why I did that. I wanted just to make sure that I only had, yeah, we're good. See, I don't have the regrade neighborhood because I had unchecked it right there. And we come back here, set that back up, elevation polygon, centroid within polygon, statistics from the raster, clipped, use only selected, and click OK. And then that shouldn't take too long to calculate that. And that's finished. And now that new surface from that new raster has been applied to the cells. Just close those because we don't need to see those. Now, what do we got here? Oh, I think I have something opened on another GIS. Okay, and everything else looks good. I can close a couple of attribute tables on my other side. And that brings us to 1213. So I'm actually done, but no, I'm not. I had one more thing I wanted to show you. And that was, two things. Okay, I don't know why you would ever want to fill a basin. I can't figure out why, but you can fill a basin pretty easily using this system. So let me, first of all, where's my basin? Okay, hang on, let me get rid of the points. I don't need those anymore. And let me pull up my elevation map. And I thought I had a basin in here. Oh, I probably deleted it when I did that select all. I might have deleted it. So let's just say that you want to fill one of these basins in here. First of all, let's confirm it's a basin and not a swimming pool or something. Or maybe you want to fill a swimming pool, who knows? Yeah, that looks like a basin right here. This looks like a basin. Oh, it's a basin and a swimming pool. Nice. So let's just say we want to fill this basin for some reason. And simple way to do this is to draw an elevation polygon around the basin. Oh, edit, create a new polygon, and we'll just do this very simply. And if you mess up, you can use the vertex tool. Oh, I didn't close my polygon. Hang on, I got to close my polygon first. Membership should be grid. Elevation, everything else can be null except the name. We'll call this fill basin. And click OK. And then if you messed it up, you can come back to your node tool and do that here. And again, we'll ignore that message because it's not important. and close our editor. In this case, it was the 10 with the boundaries, or if you assigned a single elevation, you do the polygon attributes and apply only to selected. I keep forgetting to select it. And let's see, I did this one, 10 on the boundaries, only selected, click OK, and that will fill the basin. The alternative of filling a basin would be that you're not getting the correct volume for this basin, because you're not getting the correct volume for this basin because as you can see, whenever you have a basin, these boundary cells represent a combination of elevations. So it kind of takes a little bit of the volume out of your basin. So if you wanted to calculate the volume of this area, there are processing tools. Let me see. I don't know if this is going to work perfectly or not, but you can calculate the volume. So let's get kind of like the base. Let's get the elevation off of here. What I'm going to do is I'm going to pop that kind of rim elevation off this basin using the ID tool and the original elevation data. And so you can see here that my elevation was 1426.66. And if I come over here and I click, all right, I choose volume. Well, that's not how you spell that. You can calculate the raster volume using either the QGIS, GRASS, or Saga. In this case, we have elevation as our raster. The base level is whatever that value was. Oh, for crying out loud, I forgot the value. And our ID tool left. All right, hang on, maybe I can grab that again. That's 1420, well, I think it was 1426.3, 1426.6, or let's just say 1426.4. So the base level is 1426.4. The method will be count below the base level. And let's see what happens. Oh, yeah, this one's a problem because you can't clip it to an area. So hang on. So you don't want to use that one. Let's try a different one. Let's try this one. Can we clip it? Can we clip it to an area? No, we can't. Same thing, we can't clip it to an area. So you'd have to clip it first. You'd have to clip that raster first to that area. So, which is kind of a pain in the neck. You'd think you could apply a polygon to it. There's probably a better way to do this. So let's clip it. And the best clipping tool is Saga. So we'll clip it with the elevation polygon, use only the selected feature, and clip it right here. And I think it's already done. Let's call it, nope. Okay, it's done. I think this is probably fine. I don't think anything's wrong with it. It's right here. You can see it's right here. So if you want to then try your volume, you can. Let's try raster volume. I kind of like these tools. And method, we're going to subtract volumes below the base, and our base level was 1426. And click run, and it should output a volume. And we'll see what it outputs it as. And we'll click OK. And what did it give us? It says it's finished. Raster volume finished. Outputs to, oh, here's what it is right here. So that says that the volume of that was, I don't know even what that is. So you're going to have to, oh, here we go. Base level 1426, and the volume is maybe 48,000 square feet. I don't know. I'd have to just figure out exactly how it works, but it's there if you want to figure out the volume of a basin. Read the instructions before you do it. Okay, so that's pretty much it. That's, well, 12:20, we're still there. I think that's all I wanted to cut though. You also have, you can fill rasters, you can fill parts of rasters. In Global Mapper, you can fill or cut rasters. I don't know if you can cut a raster in QGIS. I don't see why you couldn't. So I'm sure you could cut like a mountaintop or something off. That's an option. But that's it. That's pretty much it for elevation tools. Okay, Luis has a great question. How do you create a raster from the points on a grid? And this is a good question because if you're, well, typically when I have results for a Flow2D project, I would try to run Mapper to get elevation data or to get data out of Mapper. And then I could just import that as a shapefile vector layer. But if your project if you can't open your project in Mapper because it's too big or something like that, you can take a point layer and you can rasterize it. And it's not even difficult. So it's kind of goes along with this topic. So we'll just go ahead and add it today. So let's grab, first of all, let's go to projects. No, example projects. This is QGIS lesson 1. Let's see if we have some results. Yes, we do. We have some results. First of all, not only do we have results, but we also have some mapped data. So if I came here, down here, and I highlighted one of these layers, I could drag these results from Mapper right onto the map. It brings it in as a polygon layer, and I can easily convert the colors to a graduated. So I don't know if you saw what I did there, but I came to symbology. I was on a single symbol. I took off the pen because I didn't want that outline. And then I switched to graduated symbol and I set this up. Let's just use blues because it's a water and it's depth. Click, set the value to variable. That's what you get out of Mapper. Classify it, and you can choose any of these, and you can do whatever you want to the values to delineate this in the manner that you want, and you apply. And then you will get depth values from the shapefiles that Mapper creates. Now, what if you can't open your project in Mapper? It's too big. The next system would be to take that elevation or that depth or elevation from the project. So all I want from here is the path. And the depth fp.out is the maximum depth. So it's the same thing as this flow depth as cell. Come back here and add a delimited text layer. So I don't know if you saw that or not, but I grabbed this right here. Add a delimited text layer. The reason I grabbed the path is because I wanted to set my path, and then I hit the D key. Well, it's right there, so I don't have to hit the D key, but I'm going to just grab the depth fp.out. This is kind of important because all Flow2D output data is kind of always gridded. Output data is always grid element number, coordinate of the centroid, variable of the depth or velocity or whatever it is, space delimited. No header, no field identity. So the way you set that up is you go to custom delimiter, space, detect field types is okay, no field names, no headers to discard. Trim the fields, yes, absolutely. And discard the empties, yes. This one is field 2, as you can see from here. This one is field 3. I'm not worried about Z. And make sure that it's set to the correct coordinate system. That's also important. So if you need to change it, go to this guy and you can change it. Click add and click close. Now, if I want to rasterize that, I can do something very simple, I can just go to Saga. And this was the question. So Luis, we're just getting to your question right now. Okay, so go to Saga and you click rasterize. And I say go to Saga because I prefer that one, because it's kind of nice, but you can use any of these, but the Saga ones they're a bit more user friendly. The Saga tools are a bit more user friendly. So that was the layer we were on. So it automatically selected it for us. The attribute is field 4. And where did I get that from? Again, field 4 was depth. And we want the attribute first. We have to put something here, even though we don't have any lines. So I just choose the first 2 options. It is a float. The variable is a float. The output extent is important. It's very easy. Calculate from layer and then choose the grid layer. The cell size is 30. The fit, this one, I always choose the wrong one on this one, but I'm going to say the fit is cells, and that should be it, and click run. Oh, and you might want to save it to like a file. Don't just, right now I'm loading it as the temporary data. Now, if I screwed that up because I chose the wrong fit, I have to redo it. So what I'm looking for is to make sure that it's perfectly aligned to my grid. I chose the correct fit. Okay. So now we come here, wait, sorry, that's not the right one. Cancel. We come here and we symbology, pseudo color, single band pseudo color. The band is 1. The colors are blue. And you can mess with these however you want. You can change it to equal interval or whatever you want, or you can just set them yourself. You can clip out of range values. If you don't want to show all the values, you can clip those ones that are too low and apply. And you would get a depth map. It's not the best. Let's try a different. Let's equal interval. Let's try that one. I didn't get too much. Looks like what we're getting is it's too much of an equal. So you can classify it however you want, and then clip out of range. Like if you want to clip something under 0.02, it would clip, and then clip out of range values. It would clip some of that stuff out of there so you wouldn't have to see it. And of course, it looks a little better if you get rid of all this stuff and, maybe just put your cell down there. So play around with the view on, or the styling on that, because you can make it look really nice. I didn't do a very good job with that. I didn't spend too much time on it because we're only 2 minutes to the end. So that's how you create the raster from the points on the grid. And you can even rasterize your grid. But just so you know, like you can take your grid layer right here and you can rasterize it so that you would see a colored variation of your elevation or your N value or any of these other fields. You can do that too. Okay, so that's it. I will stop the recording, and if you have any questions, that's fine. We'll take care of those after the end.